Oh, hi there. Today we're going to be talking about surface area and volume of prisms and cylinders. You know, surface area and volume, it's kind of like this box of cereal. The surface area would be these sections on the outside of the box, the cover, the nutrition facts, the back, the barcode, all of that. Whereas the volume would be the stuff on the inside, how much space it would be on the inside of the box. But, we'll learn all the formulas and that stuff today on geometry. All right, so let's talk about surface area and volume in prisms and cylinders. So we're going to start actually not with surface area, even though that's in theory the lesser dimensions, but with volume, because honestly, you've already learned the volume formulas for the most part. So the volume of a prism with a base area of B and a height of h is just the area of the base times the height. Now, we don't go more specific because the fact is it depends on your shape. If we're talking about a regular polygon, then that's 1/2 apothem times perimeter. If we're talking about some sort of rectangle, it's going to be length times width, all of those things. Now, two figures with the same height and base area will have the same volume even if one is skew. Think of it this way. If you had like a series of papers, a large pile of papers, and the papers became skew, but they were still the same height and the same number of papers. So like, in other words, if like the top page began to push over a little bit, and so it was suddenly looking like that second one, the actual volume wouldn't be any different. And so that's kind of the idea there. Now, as I've said before, a cylinder is basically, and I would rather call it, a circular prism. It fits every rule of a prism except for the fact that a circle is not a polygon, although it is kind of an infinite-sided polygon. But the formula ends up being the same, area of the base times height. But a lot of times, in fact most of the time, formula charts will list it separately as pi r squared times height, which makes sense because that's pi r squared is the area of a circle times the height. Now, let's actually go with a couple of specific volumes. So the first volume that we're going to talk about here is the rectangular prism. And that volume is length times width times height. The first time you ever probably practiced doing volume, this, I would imagine, was the formula you used. The other would be a cube. Now, because every side of a cube is the same, just like we can say a square is side squared, a cube is side cubed. Hence also why we tend to say inches cubed, and so on and so forth. So now let's talk about surface area. So prisms and cylinders have two congruent parallel bases. Now, in addition to the two bases, which you can tell, for instance, in these ones, the bases would be the triangles, there are also what are called lateral faces. A lateral face is basically every side of the prism that isn't a base. We also have edges. The edges of the base we call base edges. So in other words, just the sides that form the base. The basically ones that go straight up, if it's a nice normal one, or oblique, it just any of the edges that aren't on the bases would be called lateral edges. Note that the lateral edges are not the same thing as the height necessarily. We would call the height the altitude in a lot of these cases. The lateral faces of a right prism are all going to be rectangles, whereas if we are talking about an oblique prism, at least one is non-rectangular. Notice, for instance, in the shape that we have right here, you can tell that at the very least, it appears that one of these is not. I would say the front one appears to be some form of parallelogram, but it's possible that the back one, the one that's over onto the side, wouldn't be. All right. So now let's talk about how to find or what surface area is. So surface area is the total area of all the faces and curved surfaces of a three-dimensional figure. So like I said in the introduction, if I had a cereal box, it's the amount of cardboard I'd be using for the box. Now we actually have two types of surface area. We have lateral area, and that is the sum of all the faces. So that's like that's like the space that'll be on all of the sides, but not the top and bottom. Whereas the net of a right prism you can see can be drawn so that the lateral faces form a rectangle with the same height as the prism. The base of the rectangle is equal to the perimeter of the base of the prism. So if we want to talk about the difference between lateral surface area or lateral area and total surface area or just surface area, I like to think of a can of soup. So if we want to look at, for instance, right here, the label would be a good example of the lateral surface area. And I can also, even take off this label like this. And what we're going to see is that this distance is going to be the same as the circumference of our lid. But if we want to talk about the total surface area, what we want to consider instead of the label is the entire can. So this entire can right here would be the total surface area, everywhere that we are seeing aluminum. So that is the major difference between lateral and total surface area. If we're just talking about lateral area, we want to think of it like a soup can, like just the label of a soup can. And so that's going to be, because as we just saw, the perimeter of that base times the height. So if we were talking about, say, a cylinder, that would be 2 pi r, or pi times diameter times height. Whereas if we wanted the total surface area, it ends up being that same lateral surface area, but we have to add both of our bases. So plus 2 times the area of the base. So now let's find the surface area of this composite figure. All right, so we want to find a couple of parts of this surface area right here. I'm just going to point something out here. We first need to find the surface area of this bottom rectangular prism. So it is the perimeter times the height plus 2 times the area of the base. So perimeter, so that is 9 plus 4 times 2. So that's 2 times 13. So that's 26 times a height of 5. And then plus 2 times, well, let's see, 9 times 4 is 36. So that's just going to be this part right here. So let's see, 26 times 5. Well, 20 times 5 is 100. So that's 130. Plus 36 times 2 is 72. So that becomes 202. Now we have to deal with this top figure, but I want to, before we do anything else, talk very specifically about this. Because here's the secret. I actually don't have to find this circle. I only need the lateral surface area of this specific cylinder. And that's because this circle is basically popping out from this. So rather than taking out the circle and then adding it back in, I'm just going to find the lateral surface area. So in this case, perimeter is 2 times pi times radius. So the radius is 4, is 2. So 2 times pi times the height. So times 3. So this ends up being 4 pi times 3, or 12 pi plus 202. This leads me to needing to pull out a calculator, which I will do right now. Calculate 84, and then 202 plus 12 pi gets us 239.7 approximately centimeters squared. And so that's how we would find the surface area of this composite figure. this only leaves us with one last thing that we need to talk about, and that is that you should like and subscribe. Thank you all very much for watching. This has been wonderful. Please, once again, like, subscribe, comment, all of that. I will see you all next time on Geometry.